The topic of this video is determining whether a relation defines a function. Let's look at two problems. Alright, both problems have the same instructions. Find the domain and range of the relation. Determine whether the relation is a function. The first problem is a collection of ordered pairs. The second is an arrow diagram, also called a mapping. Alright, let's begin with our first problem. It says find the domain and range. Domain is a collection of all of the inputs. So, for a set of ordered pairs, that would be the x-coordinates. So, the first thing that we want to decide is how many inputs are we going to have for this problem? Because if you can count how many inputs, then you're going to use set notation. But if you can't count how many inputs because it's infinite, then you would use interval notation. Well, there are 4 points, so 1, 2, 3, 4. I can count exactly how many. So that means I'm going to use set notation here. So I'll start with a brace. All right, so each x value is going to be listed. So we have -3, and then the next one is 7, and then the next one is -3, but the rule is that we don't list an input twice, so apparently we're only going to have 3 inputs for this problem. And then the last one is -6. So there we go. There's our domain for this problem. And again, we use braces because we can count how many elements there are. There are 3 elements. All right, now when it comes to the range, same idea, but now we're looking at the y values. 1, 2, 3, 4. I can count how many, so I'm going to use my brace. The first one is 10. The second one is also 10, so I won't write it twice. The third one is 1, and the last one is -8. All right, so there's my domain and my range. All right, so now the only thing I have to do is figure out, is this a function? So remember that the definition of a function says, a function is a relation in which each input corresponds to exactly one output. And if I quickly scan my ordered pairs here, I notice that the input -3 leads to 10, and the input -3 also leads to 1. So that's one input leading to 2 different outputs, which violates the definition, and therefore this is not a function. And this gives us our shortcut rule when working with ordered pairs. If there is a repeated x value, then it is not a function. All right, let's move on to our next problem. All right, so with this problem, we're given an input which corresponds to a particular planet, and we are given an output which corresponds to the number of solar Congress representatives. Okay, so this apparently is some sort of a sci-fi movie or maybe a future version of our galaxy where we have colonized all of these planets and there's some sort of political structure, and these are the number of governmental representatives of each planet. All right, so we're going to do the same thing as before. We're going to start with domain. Domain is a collection of all of the inputs, which we can count. 1, 2, 3, 4, 5. And since you can count how many there are, you use a brace. All right, so now we just have to list all of the inputs. So we have Venus, Mars, Jupiter, Saturn, Neptune. All right, next is the range. Range is a collection of all of the outputs. Well, I see 18, 21, and 39, and every one of those has an arrow pointing to it. So that means every one of those is actually going to be in my range. By the way, if there's ever a value listed in a mapping, but no arrow leading towards it, that means it's not actually an output, so you wouldn't include it in the range. But for this one, they all have arrows pointing to them, so we include them all. All right, and then the last thing we want to determine is this a function or not? So we have to apply the definition. The definition says that a relation is a function if, for each input in the domain, there corresponds exactly one output in the range. So let's look. Venus is an input that goes to 18 and nowhere else. Mars is an input that goes to 21 and nowhere else. Jupiter is an input that goes to 21 and nowhere else. Saturn is an input that goes to 39 and nowhere else. Neptune is an input that goes to 18 and nowhere else. So yes, this is a function. Now, the shortcut rule for working with a mapping is if there is more than one arrow leaving an input, then you can conclude that the relation is not a function. And I don't have a lot of space to write that here in a full-on sentence, so I'm going to write FCN to represent function, and then I'm going to write the little universal symbol for not. Now, when I teach this to students in a physical classroom, what I usually do is I grab a cloth and I cover up the right-hand side of the mapping. So in this case, I'm just going to do that with this little pad here. So if you were to count the number of arrows leaving each input, you would see that there's 1, 1, 1, 1, 1. If you get ones all the way down the line, then what you're dealing with is a function. But if any of those inputs has more than one arrow, then you would conclude that it is not. All right, we've now finished both of these problems.